Hello everyone, welcome back. So in this video we can talk about analysis enabling variables. So myself Ali Sheikh, I'm a consultant at Trilam Dipma Inc. Okay, so what exactly the analysis enabling variables? Okay, let's continue with this one. So here we have the introduction, the training module provides a comprehensive overview of the analysis enabling variables within the ADAM framework essential for the robust clinical data analysis. So we'll be having different sections here. You see general ADAM definitions and the parameter criteria variables for PDS datasets and the descriptor variables. So indicator variables, all these sections, if you go to sections there, so you can find out this information there, and they will be also having the reference materials. So this training will focus primarily on the analysis indicator, analysis descriptor variables within the main ADAM IG. So that can be used within the ADAM datasets. Okay. Next, so here the table of contents. So first we go ask to discuss about why analysis enabling variables, understanding their critical role in facilitating precise data analysis. Then we'll discuss analysis descriptor variables, examining variables that describe the nature of derived data, and the types of analysis flags, the categorizing variables used to select record for analysis. Then we'll be having the criterion variables and multi-criterion variables and the further considerations. Okay, so this training is focusing on variables you can add to implement analysis needs. Instead of the analysis results, the parameters themselves, analysis enabling variables is defined as a column or a row that would be required to perform a given analysis. Okay, so the variable, so the definition, the main definition of the enable variables are essential for defining and selecting the precise subset of the data required for specific analysis. Okay, so they act as a filters, ensuring that only relevant records contribute to the statistical outcome. So the analysis parameter criteria variables as per IG table section 3.3.4.2, these define criteria for analysis parameters such as specific visit windows and subject populations. And analysis descriptor variables outlined in these sections 3.3.5, where they have a derivation type like D type, analysis visit windowing, which explain how analysis values for derive are adjusted. And then indicator variables, if you go to section 3.3.8, so these are the binary flags, yes or no, or 1 comma 0 boolean values, so that indicate whether a record meet specific condition for inclusion in an analysis. Okay, so the first one, the analysis descriptor variables. Okay, so understanding the analysis descriptor variables. Analysis descriptor variables provide a crucial metadata about the analysis ready data, so clarifying how values were obtained or classified. So this transparency is vital for ensuring the reproducibility, interpretability of analysis. Explain the derivation of analysis values, example mean, change from baseline, and specific analysis visit windowing. So there are key types. A derivation type, D type, indicate the method which analysis value for derive, and analysis visit windowing concepts. So define the time windows used for aggregating or selecting the data points for analysis visits. So the analysis descriptor variables, D type, explaining the derivations. So D type variable specifies how an analysis values were derived. This is particularly important for non-raw values such as average, change from baseline, or last observation carry forward. If a value is an average of multiple measurements, D type would indicate average. This ensures that analysts understand the nature of the data they are working with. Okay, so for example, which method we have used to create a new parameter, then the D type would be indicated as average. So the D type value should align with the CDISC ADAM terminology, promoting consistency across study. I'm not asking for the new parameters, it's eval values. So if it is a missing eval values, and if as per the SAP how they want to derive for the missing, how they want to impute that missing, so on the time the data will be populate, and it will ask you for what method we have to use. So the D type is optional for raw values but critical for derived values, so to maintain the data lineage and interpretability. Okay, so the D type, here one example, consider the clinical trial where subject weight is measured at a multiple visits. Okay, for analysis uh, an average weight up to week 8 might be derived. So the derived variables identify these derived values. Here we have the average, you see, is for average to week 8. So this is the taking the week 8. Okay, so the clinical for is measured in the multiple visits. Okay, so this is the average of all these visits. Consider 78.425 for this record. And what is the method they have used? Average. Then this d type variable, the derivation type variable indicated as average. This example clearly demonstrates how d type enhance the transparency for derived variables values. So the types of analysis flags. Okay, so the types of analysis flags, the analysis 01 flag is a general purpose analysis flags where ZZ is a sequential 2-digit number, is a 0102. It is used to identify the records relevant to the specific analysis dataset or statistical evaluation. A value of Y indicates inclusion while no or blank indicates exclusion. So this flag ensures only appropriate data points are considered for a particular analysis. Each analysis 01 is typically accompanied with numeric format as well. FN analysis flag for a reason. So a variable providing the numeric code and description for the reason record for was flag. Example 1 for included in the primary analysis, 2 for excluded due to missing data. And here is an example. So if the in this example, analysis 01 flag indicates records included in a primary analysis. So analysis 01 equal to 1, signifying the data within the predefined visit window. So records without Y flag or FN indicates exclusion. Example, multiple measurements of the same visit for a single. So here is the days, like the variable name is missing, but this is the one. The Y indicates the record for the primary analysis. So this record we consider for the week 2, we indicated for the primary analysis, and the one the numeric format is 1, signifying that data with the predefined visit window. Okay, so this is example 2. So in this complex scenario, the flag records with a predefined visit window, while analysis 02 flag specifically flags record AWDIF actual minus window target difference, so less than or equal to 1 day. This allows the fine-grained selections of the data point based on the multiple inclusion criteria. Okay, so on treatment record flag, this is another record analysis flags. On treatment record flags are crucial for identifying the data collected while a subject is actively receiving the study treatment. So the most common is the on treatment flag, which indicates whether a record falls within a period from a first dose date to the last dose date plus a defined treatment cessation window. And the numeric format of on-treatment flag provides further data such as 1 for the on-treatment period first dose to last dose, or 2 for the post-treatment to extended to follow-up. So 1 represent to start with the first dose to last dose, and 2 represent to the extended to follow-up. So these flags are vital for analysis, focusing on the treatment emergent events or efficacy during active exposure. So next one, the criterion variables. The criterion variables define the specific conditions or threshold that data point must meet to be considered relevant to for particular analysis. So they are distinct from analysis flags, which simply indicate inclusion and exclusion. Criterion variables allow for dynamic subsetting for data based on clinical or statistical relevance. So the criterion variable uses diverse deliverables. The criteria are applied across the various outputs, including identifying out of a range vital signs, specific lab measurements, or questionnaires. Scores taken at a particular visit. Questionnaire scores taken at a particular visit. And it is also helpful the clear selection path when combined with analysis flags and subgroup variables. Okay, so the criteria variables create precise and data selection for any analysis, ensuring the rigorous data governance. And ADAM analysis data model guidance supports two primary ways to use criterion variables in clinical data analysis: derived criteria and evaluated criteria. So the crit y analysis criterion y. So crit y is a criterion variable that stores the actual criteria logic, where y is a sequential number. It is a typically character variable that holds the verbatim text of the criterion condition that was applied to a record. For example, crit1 equal to aval greater than 100 would indicate that analysis value that record exceed 100. So these variables are often used when the criteria themselves are dynamic or needed to explicitly document within the dataset for traceability and reproducibility of the analysis. They allow for complex conditions to be expressed clearly. And the crit y flag is a flag variable that indicates whether a record meets a specific criteria. Similar to analysis flag, a y typically means a criteria is met and a blank or n means it is not. And the criterion y reason provides a numerical or textual explanation for why a record met or did not meet the criteria. This details is essential for debugging, analysis, and understanding the population characteristics based on the specific criteria. For example, crit1 flag equal to y could have crit1 fn equal to 1 meaning met efficacy endpoint, or criteria 1 fl equal to no with criteria fn equal to 2 meaning did not meet safety threshold. So here is an example for the criterion populated when criterion is met. So the crit variables indicate a specific criteria has been met at the record level when the condition is true. So if this is the condition is true, because less than or equal to 80, this is 75 here. So the criterion flag represent y and the in the numeric represent as 1. So if the heart rate is below 80, so this value is 75, our value is 75. Okay. And the crit populated across all records in scenarios require criterion evaluation for all records related to the parameters is populated uniformly. This ensures a complete assessment even for records not meeting the specific condition. So here if this is like less than or equal to 80 and this one eval value is 86, and it represent no because it's not meeting the condition of the criteria. And also for the numeric it represent as a 0, which means it's not met the specific condition. An example 3, criteria creating the new parameters for multiple rows. When criterion depends on information spanning multiple rows or new parameters can be derived. So this is a critical for complex criteria like combining heart rate or weight conditions. So this new item variables, this simplifies analysis by consolidating interrelated data points. So here we have a two criteria. The heart rate is less than or equal to 80 and weight greater than 75. So the both cases are meeting that criteria. So then it will give as a two flags as a y. Okay, and the numeric will be having 1. So the multi-criterion variables. The multi-criterion variables extended the concept of criterion variables to scenarios where multiple conditions or responses must be evaluated simultaneously. So these variables are crucial for capturing the complexity of the clinical data and deriving more nuanced insights, such as toxicity grades, increases over time, and composite endpoints. So the multi-criterion variables, so they have a definition like these variables capture complex responses where a single criteria isn't sufficient. So they often involve multiple parameters, time points, or conditions. And what is the purpose of these multiple criteria? It enables the analysis of composite endpoints or specific sequences of events, providing a more holistic view of a patient outcomes or adverse events. And an example to use the tracking changes in toxicity grade, evaluating the progression-free survival based on the multiple assessments, or identifying the patients meeting a combination of the eligibility criteria. So these two cases is we will be using the multiple criteria variables. So here we have some variables, the long label, the numeric. Okay, so the long label provides a descriptive human readable label for the multi-response criteria and useful for the reporting and interpretations. And the numeric of these long labels offer a concise numeric representation for the criteria suitable for programming and statistical analysis. So the use of these pairs ensure both clarity for human understanding and precision for computation analysis, facilitating seamless data flow from the programming to reporting. So here is an example to illustrate application of the multi-response criteria for tracking hemoglobin toxicity grade increases over time. Okay, so it describes the grade change and quantifies the increase, demonstrating how these variables enable granular analysis of adverse events. So here we have hemoglobin response, right? and it indicates. So here we can see grade increase and no increase, the one level increase. So they have to monitor the hemoglobin during the visits, like how their values are changing, if it is increasing or decreasing based on the criteria they have kept it. Okay, so we can monitor if, like for example, toxicity grade, that how the grades are changing during the visits. So you can use these flags and to identify if the grade is increase or decrease. So the next one, the further consideration. So what variables are best for analysis? So the direct relevance, prioritize variables that directly answer research questions or define key endpoints, avoiding the creating variables purely for convenience if they don't add analytical values. And clarity, interpretability. Choose variables that are clear, unambiguous, not to have confusions, and easily interpretable by clinical or statistical teams. By using these variables, the multi-criterion variables, and to minimize the redundancy to avoid duplicate information. So if an existing variables can be reused or repurposed. So for future proofing, consider how variables might be used in the future analysis or integrated into broader data initiative designed for flexibility. Okay, so we have, these are the flags we have to be comprehend to understand. Okay, all right, that's it for this analysis enabling variables. Thank you so much for watching.